Hi, good morning all. Srinivas here. Hope I'm audible. Could you please confirm I'm audible? Okay, thank you. Thank you, Samyu. Okay, let me share the screen. Today we are going to discuss about the hardware, that OS and applications and users, how the correlation. This is a day 2 of VMware administration session, and we are going to discuss about hardware, the OS, application and users. So hope you are able to see the screen. Okay, see here. Before understanding this virtualization, we need to understand a few technical points. The first thing is that how the resources, hardware resources are sharing to that respective user. What is a user? If you see in this particular picture, the bottom layer is a hardware, wherein hardware is nothing but that processor, RAM, and IO operations. IO operations in the sense it is a network and the storage that is considered as a hardware layer. On top of it hardware layer, we are going to talk about the operating system. How the operating system is coordinating with the hardware and what purpose it is coordinating. Why we are using operating system? We are using multiple applications on operating system wherein the users are able to access. For example, I'm using the laptop. In this particular laptop, if I see I'm using Windows 11 on laptop hardware, how many applications are using the same OS layer? Each application layer, what are the resources are sharing? Like if you see, this Zoom meeting is consuming this much of CPU resource, this much of memory resource, and the disk space, how much disk space, the throughput, IO operations, and network operations. So each application, it is going to use based on the user interaction. Okay, so what is on key point here? How the resources are sharing to that applications. How many applications are there here? There are multiple applications are available in this particular task manager, wherein each application is getting a resources. Who is assigning resources? Is this application directly coordinating with the hardware to get the resources, or who is taking care to assign resources? In this particular picture, if you see here, that operating system layer is coordinating with the hardware layer and sharing the resources to the respective applications. Who is using that applications? Users are using that applications. So here what we need to understand is how the resources are sharing to each application. The layer in this particular the architecture, the outer layer, if you see that outer layer, it is a complete hardware. On top of hardware, the operating system. On top of operating system, application. So application is going to get the resources. Okay, what the resources it is going to for each application. For each application, what is required? To use any kind of application, we need to install. Where we are going to install, it requires an operating system. Once it is installed, it is going to consume some space from the storage, and it is going to execute based on the processor instructions, and it is going to buffer in the memory to execute that application, and user is able to access that application, right? So here in this particular picture application, how the resources are getting, what resources we are going to talk about. That is a relation between the first point, hardware versus operating system versus applications versus users. Okay. Any doubt on this point? What is the applications are used and how the applications are getting resources from hardware? Why we need to understand this particular layer? Because the applications we are going to replace, the application concept, it is going to replace as a virtual servers in a virtualization layer. So that virtualization layer, how the resources are sharing to applications. In this virtualization layer, applications is nothing but virtual servers. I'm going to explain. That's the reason I'm explaining this particular concept. Each application, how the resources are sharing, how much storage it is using, how much network it is using, how much CPU and memory. So if you come to the point, the resourcing sharing concept, how application in your mobile as well. If you consider Android mobile or any mobile, you are going to use different applications, Google Pay, Phone Pay, and all those things. For each application, it is going to consume the resources, how the resources are getting from Android OS or Apple OS, and from where it is getting, underline the hardware. Underline hardware, what we need to understand here, what is the resources? What is the components of the main components of the system component? How we are going to call it as a system, a hardware, to consider as a either it is a desktop or either it is a server, whatever it may be. So how we are going to consider as a system? So in this particular topic, we are going to use the major 5 components to consider as a system. What is the major components? The motherboard, the processor, the memory, storage, and network. These 5 components I'm going to consider as a system. For take an example of your laptop, whatever the laptop you are using. In the laptop, you are considering as a system, the motherboard will be there, and the processor will be there, memory and storage and network. Without these 5 components, I'm not going to call it as a system. Okay. So entire virtualization is going to depend on these 5 components. How we are going to call it as a system. Okay. So before going for further, do you understand what is a desktop versus server? Anyone? What is a desktop and server? Can anyone please unmute yourself? Friends, it is a kind of interactive session. It is a virtualization wherein you need to understand each and every topic from the scratch. Okay. The virtualization, how this picture is going to come into picture. We need to understand physical layer. By understanding the physical layer, you are going to imagine the virtualization is nothing but everything is imagination, virtual world, wherein you are going to think about a virtual server by understanding the physical server, physical hardware. You are going to imagine how it is going to be in a virtualization layer. That is virtually how it is going to represent. So this is a basic understanding hardware components. I'm going to showcase what is the hardware, these 5 components, how it look like, and all those things. Okay. Before proceeding further, I would like to get some information from you. What is a desktop versus server? Anyone? Can anyone please? Will you able to unmute yourself and speak up? How can I say a desktop processor? Yeah, please.
Myself, Srinivas. Server is a device which gives services to the other receivers.
Okay, whereas in desktop?
Desktop is not as much of a facilities provided by the servers. It's like a minimum hardware availability device which can use personally.
Okay. Okay. Can I define in other way that desktop is a single user interface, whereas in server is a multi-user interface? Can I say this?
Yes.
A desktop, your laptop is a single user interface, and the server is a multi-user interface. Okay. So as you are working on a laptop, I'm using a single user. I'm going to say it is laptop as a desktop. Whatever the system I'm using, that system is nothing but a combination of the 5 major components, that is motherboard, processor, memory, storage, and network. So my laptop, I am going to call it as a desktop. Okay. So for each and everything, we need to segregate, we need to understand how the hardware it is combination. What is a desktop? What is a server? What is a major difference? Can I run my laptop continuously 24 hours, 365 days? No, right? That capacity, the power consumption, that form factor, and the performance of the each component depends on how effectively we can run the server hardware continuously. If I run the laptop, whatever the desktop you are going to use, if I run the laptop for 24 hours, the system is going to get heat and it is going to freeze. It is going to unresponsive state because of heating components. So the performance of the hardware, it is always depends by deciding factor of is it a desktop hardware and server hardware. Why we need to choose desktop hardware, why we need to choose server hardware? It is all depends upon how many users are going to access that particular device. Based on the users, we are going to derive either I need to go with the laptop, either I need to go with a server, right? So not only that, for example, there is a IRCTC website is there. How many users are going to log into that website? So how many sessions are going to establish? So to each user, if I'm not going to maintain a proper hardware, that IRCTC website, it is going to choke. It is not going to respond. It is going to, I'm not in a position to book the ticket. So I need to make sure the underlying hardware should be in a high performance to support those many user sessions, right? So coming to that, I'm going to showcase for each and every understanding that these 5 components, what is a motherboard, what is a desktop and server motherboard. I'm going to showcase you, even you can Google it. What is a desktop versus server motherboard? See here in this particular picture, if you see, there are 2 motherboards are available. I hope you know what is a motherboard. Without motherboard, we cannot connect the processor, we cannot connect memory, we cannot connect any devices. All devices are going to connect to this motherboard. From there, we are going to achieve the desired functions, right? So the desktop motherboard versus server motherboard, okay? Different types of motherboard. what we need to understand by looking at this motherboard, what is a processor socket? What is a socket where we are going to install the processor, where we are going to install the memory? So based on this processor and memory capacity, we are going to choose the hardware, what hardware I need to choose. Okay. So even desktop versus motherboard, if you go to Google, you can search different combinations, how we are going to search, how we are going to understand. We need to understand what is the importance of these hardware components. See here, what is a component on from this motherboard? What is the important components we need to understand by looking at this picture? What is a socket where we are going to install the processor? That is first thing. Second thing is that how much memory it is can support. While purchasing a mobile, you are going to see what is the support of processor, what is a memory support, what is a storage support. While purchasing the mobile, you are going to cross check, right, these components. The similar way, we need to understand the specification of the server hardware, how much processor it is going to support. Is it a desktop motherboard or server motherboard? As I am looking for server motherboard, I need to choose specific to support high performance configuration. High performance configuration in the sense, the motherboards will be there with a 2 processor sockets, 4 processor sockets. If you see in this particular motherboard, I can say this particular first motherboard having 2 sockets. 2 sockets in the sense, I can install only 2 processors. Whereas if you come to this particular motherboard, what is the capacity? I can install 4 processors on this particular motherboard. And at the same time, how many slots are available to install the memory? If you see in this particular motherboard, each slot it is going to designed in a such a way that what is the capacity it can support. So based on that capacity only, the server price is going to increase, because as we are working on virtualization layer, we are not talking about a single server. By using this virtualization layer, we are going to host multiple servers. On a one physical server, we are going to host maybe 50 servers or 70 servers or 100 servers based on the configuration. That's what we need to understand, what hardware and what is the specifications it can support. Okay, how many sockets are available? Without understanding what is a socket, what is the memory slots available on the motherboard, we can't estimate the capacity, the performance of this particular server. So the first component is how many, what is the capacity of motherboard? That is the important point. Okay, if you go to the desktop motherboard, if you go to desktop motherboard, generally it is going to have single processor socket. Generally laptop or wherever, whatever the place we are going to check, it is going to have a single processor. See here, this particular motherboard, I can say it is a desktop motherboard wherein it is having only single socket, and even the socket design, everything will be differs. Okay, so what is a desktop motherboard? What is the server motherboard? By understanding the specifications, we can come to know, right? Is it clear on the motherboard? What is the importance of the motherboard? That is a point we are going to discuss about desktop versus server motherboard. Okay, it is very much important during the virtualization. Virtualization is nothing but we are going to host multiple servers on a single hardware. So we need to think about what kind of high performance server we need to choose. Okay. Coming to the desktop versus server processor. For everything, I'm comparing desktop versus server. Why? Because as you are learning data center virtualization, you are going to deploy and understanding virtualization layer. That virtualization layer, what hardware we need to choose. Okay, the picture should not come into picture. Shall I go with this particular hardware? It is your own understanding that what hardware I need to choose. By looking at the specifications, I can say that this is not compatible. Okay, we need to choose high performance in each component area. Those, what is the 5 components? Motherboard, processor, memory, storage, network. Okay. Guys, whenever you have any doubt or at any point of time, you are happy to interrupt me and post your questions. Yeah. Okay. Coming to the processor. See here, if you go to Intel site or AMD site, the processor different architectures we are going to see. For example, if you go to Intel, products, under processors, if you see, this is a processors category. If you see, there is a Intel Xeon and the Intel Core is there. If you go to Intel Core, you can see what is this processor. Is it a desktop processor or a server processor? See here, whenever you are going to consider in your laptop, you will find my laptop is i5, i7, okay? The server processors are going to be considered as a Xeon processors, okay? What is the difference between specification between the server processor and desktop processor? Okay, you can see the differences. What is a cache? What is the number of cores? I am going to explain while discussing about processor. I'm going to provide clear information, what important factors we need to understand in the processor configuration. Okay. In this particular processor, do you know what is, while saying that mobile configuration, my mobile is quad core processor, octa core processor. Okay. What is that configuration? What does it mean? What is quad core? What is octa core? Can anyone?
I think cores is the pins are actually. So dual core means two square cable came. Quad core means four types of square scans. And each socket, each core has a separate pins.
Okay. See, the dual core, we are going to call as a quad core, octa core. What does this mean? Sorry. What does this mean? The concept is here. If you see the configuration of the specific processor, if you see here, what is this? For Core i5 processor, it is a single chip. I'm telling that it is a single chip and it is going to install a motherboard, laptop, desktop motherboard is going to have a single socket. Single socket in the sense, the physical processor chip, whatever the chip you are looking at here, this particular chip is going to insert on the particular motherboard, right? If you see here, up to 4 cores, 14 cores, if you see here, up to 14 cores. What is that 14 cores? It is nothing but it is going to provide in a physical single processor chip, it is going to provide 14 logical cores. If you say, I'm going to say my mobile is a dual core processor, but in our mobile, it is going to have a single chip, but it is going to act as a 2 processors, dual core. Dual core in the sense, The physical component is one processor, whereas in it is going to execute 2 instructions per second. That is a performance matter. Okay, so like that, quad core in the sense the chip is only one, whereas in it is going to perform 4 cores within a one physical. That 4 cores I'm going to call it as logical core, logical processor, logical CPU. You should understand what is a physical processor, what is a logical processor. I'm stressing here the cores, CPU. I can call it as a processor, I can call it as a core, I can call it as a CPU. All these terminologies are referring to only same thing, but you need to segregate between what is a chip. This is a what you are looking at this particular picture. It is a physical chip. The physical chip is going to act as a according to the configuration. Like if it is a dual core, it is going to work 2 cores, 2 processors within the physical chip. 2 logical processors will be. How it is happening? That in the sense, it is going to execute 2 instructions per second. If it is a quad core, it per given second, it is going to execute 4 instructions per second. Okay. Similar way, for this particular processor, whatever the processor we are looking at, this particular processor is capable of perform 14 logical cores within one chip. That is information here. See here, first one i9 processor. How many cores are there? Delivering up to 24 cores. That is one physical chip. There are executing instructions for a given second, 24 instructions. Why we are looking for performance? The matter, whatever the applications we are going to use, number of application, each application requires CPU instructions to execute that application. If I am looking for more applications execution at the same time, that underlying hardware, that CPU should support those many applications. If I'm not providing sufficient processor capacity, what will happen? The application is not going to work as expected. So in this concepts of understanding what is a physical processor, what is a logical core, CPU versus, I'm going to mention physical versus logical. How the logical is going to come into picture? Dual core, quad core. Dual core in the sense, it is going to be 2, it is going to be 4, if it is going to be 8. My mobile is octa-core processor. Smart Dragon octa-core processor, they will say that. That means that processor is capable of execute 8 instructions per a given seconds. Logically, it is going to showcase 8 CPUs. Okay, that is octa-core. It is all depends upon the processor specifications and respective configuration. If I go with one more website, sorry. I'm going in again Intel site. There is a AMD site is available. The AMD processors also, server processors are available, desktop processors are available. Okay. See here, Intel Xeon. What is an Intel Xeon? What is the capacity? How much core it is going to support? There are different families are there. I'm going with Intel Xeon E processor. Okay. So each configuration, the products. See here. This is a processor And what is the number of cores here? See here, 6 cores and 8 cores. There are processors are available in a server processor hardware, wherein even the server, one physical chip can support more than 40 logical cores. Okay, so that is a capacity, depends upon if I want to install that high capacity processor in a motherboard, where we are going to insert this processor, what are the processor we are going to purchase, that processor has to sit on the motherboard. Okay, so I need to choose a right motherboard, I need to choose the right processor. Generally, hardware is going to provide as a bundle, and they are going to provide a specification. This server can capable to expand this much capacity. The memory can be expand this much capacity. How it is possible? We can change the processor. If the motherboard supports, initially the motherboard is coming from the 4 processors. If I want to upgrade the motherboard, I need to choose what is a compatibility processors available. I can go with 8 processor, 8 core processor, or 8 core processor like this. Okay, so we need to understand what is processor information for server. Okay, what is the specification? Yes, please.
What is the speed there?
A bit louder, please.
What is the speed there for 4.60 GHz?
4.0. Okay, okay. See here. This is a gigahertz, the frequency of the processor configuration. For example, if I say that the processor is physical chip, I'm talking about a physical chip. Okay, let me clarify. It is a, you are looking at a physical chip, right? That physical chip, the configuration, speed, the speed it is going to mention, how much gigahertz. For on your laptop, you can see it is supports Intel i5 3.5 gigahertz. Gigahertz in the sense giga, kilo, mega. That giga is there, right? That is capacity. That's money. Number of instructions, cycles. The giga has those many cycles it can support. Okay, kilo means 1000, mega means into square like that. So gigahertz, whatever the configuration it is showing here, it is showing a gigahertz. Thus much cycles it can support. Once how much fast it can work that instruction. That is a cycle. Okay. Processor base frequency, maximum turbo frequency, and cache. What is a cache? Cache is nothing but it is going to cache that configuration instructions in cache, and it can support the same information is available. It is going to fulfill, improve the performance. Okay, so all those things it is going to matter in CPU configuration. For virtualization layer, what we need to understand is major components we need to understand in the processor. What is physical chip? How many cores it can support? For example, motherboard is 2 sockets. You know what is socket? I hope it is clear. Motherboard, the socket is required to place the processor, right? Now motherboard has 2 sockets, right? Now I'm going to install a Xeon processor. Xeon processor capacity of 10 cores per chip. That CPU configuration 10 cores. If I am installing in both the sockets, how many cores I'm going to get? How many total cores I'm going to get? Anyone?
20.
Yes, 2 sockets are there. I'm going to keep install those 2 processors. 2 processors into each processor can support 10 logical cores. So total capacity of the system, that hardware, is going to get 20 logical cores. Logical cores, I can say a 20 CPU, I can say. Okay, is it clear?
Yes.
So
Any
speed
doubt?
is 20. So speed is 20 into speed or 2 into speed?
Sorry, a bit louder, please.
Speed is 20 into speed or 2 into speed? So 2 into speed.
2 into 10.
Speed.
See here,
You talk the
Gian,
speed, right?
clock speed is going to come into picture when we, for example, 20 cores are there. Okay. Clock speed, it is coming into picture when we are going to work on the virtualization layer, how much capacity is available. Now, the basic hardware, what we are going to look at, the cores and physical. That is the difference. We need to understand how many logical cores we are going to get. Now, if you count a total CPU capacity, for example, if I take this particular example, this is the base frequency of each core. Okay, for example, 3.5 gigahertz. So I need to multiply these two sockets, both are same processor, 20 cores into 3.5 gigahertz. That much CPU is a total capacity. If you mentioning the capacity as a CPU, I'm going to mention 20 CPU. If I'm going to mention as a speed of the total CPU capacity, I'm going to multiply 20 into each processor capacity, that is 3.5 gigahertz. That cycles. Generally, while talking about a virtualization layer, we are going to mention how much CPUs it is going to support, how many cores available on the motherboard. Okay, clear?
Yes.
Okay. Now, the important one more component is, while working on virtualization layer, by default, the motherboard, the BIOS, we are going to call it as the BIOS. I hope everyone aware what is a BIOS, wherein we are going to see the specifications and configuration of the BIOS settings, where we can change the processor setting, we can change the memory settings, we can change disk settings and all those things in BIOS. Okay, under processor, the BIOS, the motherboard having a program, that is BIOS program, we call it as. While entering the BIOS, I'm going to showcase while working on Dell PowerEdge server, everyone able to see how to check the BIOS setting and what important parameters we need to cross check before going for virtualization. Those are two important configurations under processor settings. Under processor setting, two important components will be there. One is virtualization compatibility. Virtualization compatibility. By default, whatever the hardware we are going to purchase for virtualization purpose, then BIOS, the virtualization by default will be enabled. Without this enable, if the virtualization is not enabled, you are not in a position to install any kind of virtualization. Okay, any kind of virtualization is not going to support if the BIOS virtualization concept is disabled. Okay, this is one important factor we need to see under processor. And one more important thing is hyper-threading. Hyper-threading. Hyper-threading, what is a hyper-threading under processor? This hyper-threading feature, as we mentioned here, what is how many processor it is going to support? This motherboard has a 2 sockets. Okay, and by installing 2 processors, total 20 CPUs I am going to get. Okay, now this particular processor, and wherever we are inserting this processor on a motherboard, if the both are compatible for hyper-threading, then my CPU capacity will be double. Now, hyper-threading is enabled on the motherboard, and CPU, that whatever the processor we are going to install, it is supports hyper-threading. By default, the total CPU count you are going to see double. That means 20 into 2. So how many total logical cores I'm going to get now here? Total logical 40 logical cores. It is a hyper-threading feature. By default will be enabled in each and every hardware which we are going to use for virtualization. What purpose we need to make sure everything is in support of high performance. Okay. Is it clear? These two terminologies under processor, we discussed about what is a desktop processor. We discussed about server processor. Coming to the server processor, we discussed about what is a dual core, what is quad core, octa core, what is a concept, and how many total cores we are going to get while installing on respective processors in motherboard. That's what we consider as a 2-socket motherboard. If I consider as a 4-socket motherboard, for example, there is a 4-socket motherboard is available, and each processor, Xeon processor can support, for easy understanding when selecting, Xeon processor supports 20 cores per processor. 20 cores. Now, how many I'm going to get as logical cores? How many I'm going to get? 4 into 20. Total, how many cores I'm going to get? Total 80 cores, right? If hyper-threading is enabled,
160.
so it is going to be double, right? So 80 becomes 160. Is it clear? Any doubt?
Yeah, I think I'm getting confused. So you said 4-socket on the motherboard, right?
Yes.
The Xeon processor support 20 cores. What is 20 cores means? Can you? I think I lost that.
Yes. Okay. Very good. See here. Xeon
Each socket
processor.
support 20.
Xeon processor is a physical chip. Okay.
Okay.
Each chip is specification. As per specification, it can solve how many logical cores within a single physical chip. How many logical cores it can support. Where I'm going to get from here. See here, this is a Xeon processor. What is the cores capacity for this particular processor configuration? 6 cores, right?
Okay.
You see here, like that, each processor based on the processor configuration, each processor, now I considered this in this particular example, it is going to 20 cores. This is a one kind of processor. Each model is going to get a specification for each processor, how many cores it can support. Okay. In this example, I mentioned that this particular Xeon physical chip processor can support 20 cores within 120 logical cores. That will be clear. Logical cores or logical CPU. This is a configuration of that particular chip, that processor chip. Okay. So by understanding this particularly, as it is going to support 20 logical cores within one physical chip, this kind of processor I'm going to insert in these 4 sockets. 4 sockets are available. In each socket, I'm installing this kind of capacity chip in this each socket. So what I'm going to do, 4 processors I'm going to install. Each processor can supporting 20 logical cores. So 4 into 20, total how much capacity I'm going to get? 80 logical cores. Is it clear?
Yeah.
So once it is 80 logical cores are available, this is according to processor configuration. There is one more configuration parameter By default, each processor hyper-threading supports available, by default enable. If you enable hyper-threading on the motherboard, that motherboard BIOS setting under processor, this hyper-threading option will be there. Some motherboards, there won't be any option available. Some motherboards will be there. If it is available, I can enable or disable. If it is enabled, whatever the processors installed on the motherboard, it is 80 logical cores. But because of compatibility of this motherboard capacity, the processor it is going to support and becomes as a double, and motherboard and processor going to coordinate handshake with both each other, and the output it is going to give, instead of 80, it is going to give 160 logical cores. What is the 160 logical cores? For a given second, it is can execute 160 instructions per given second. Okay,
Got it.
that high performance, we are going to achieve high performance.
Got it. Thank you.
Okay,
Okay.
see here.
What is
Yes,
the speed
please.
now? 160 into total speed, or 80
Speed,
into speed?
okay, speed, while considering speed, we have to calculate this logical process speed only. See here, if you go here, where is it? See here, what is this? Processor base frequency. What is that maximum turbo frequency? Turbo means if it is hyper-threading is enabled, that each processor initial configuration 3.5 gigahertz. If it is hyper-threading, here they are calling as a turbo frequency, the max we are going to get 5.10 gigahertz. That means you need to calculate 160 into 5.1. Generally, it is not going to consider in calculation, capacity calculations, while working on fine-tuning and VMware recommended approaches. We are going to discuss about another concept wherein how many vCPUs. I'll talk about vCPUs later. Just I'm explaining. For one CPU, how many virtual CPUs we can assign? Virtual CPUs in the sense we are going to deploy virtual servers. For virtual server, each server we are going to assign CPUs. So during that concept, first we need to understand physical component, then we are going to understand physical virtual CPU. Okay, that virtualization kernel, that it is going to take that performance metrics as per recommended. Okay, we no need to count this gigahertz. Leave this point here. Only the concern is what we need to learn from this particular CPU concept. What is cores it can support a single physical chip? How many cores it supports? What is hyper-threading? These two important terminologies from this particular processor, hardware processor concepts. Okay, clear?
Okay.
Any doubts on the processor? Okay. Now, going to the next topic, that is desktop versus server memory. See, even memory capacity also, desktop memory is one thing. For everything, you can Google it and understanding the concepts. Same thing I'm then typing here, desktop versus server memory. You can see server memory is different, and the configuration, that form factor, because the server is going to run continuously 365 days, 24 into 365 days. And whatever the electronic device we are going to use, that electronic device should support maximum efficiency, maximum durability to support maximum workloads. Whereas in desktop, if you see desktop motherboard, if it is laptop is continuously running for a longer run, you are going to, the application is going to freeze. Server, the desktop is not going to respond. Even if you move mouse, it is not going to respond. It is going to take more time to open application. In server memory, there is a additional checks will be there. Okay, error correction check. One is ECC, we call it as, that is additional configuration. What we need to understand, how much memory it can support for each motherboard. There is a concept of how much memory it can expandable. By default, while purchasing the server hardware, it will be come with a default configuration, and it is going to mention that currently it is a 64 GB is available, but the server is capable, the motherboard is capable to expand that memory configuration from 64 GB to 64 TB or 120 TB, 128 TB, like that. So what kind of memory modules? Memory modules is a factor. 4 GB modules will be there. 4 GB modules, 8 GB modules. It is going to multiply factor. It won't be, there won't be any 6 GB and all those things. It is, there is a memory architecture dependency. So these modules are available in this configurations. How many slots we are going to use and what type of memory chip we are going to use, we are going to get desired out. For example, the motherboard has a 10 slots, 10 memory slots are available. Okay, till now we discussed about desktops socket, the processor socket, how many max 2 or 4 will be there, whereas in memory slots it can vary from many, like some motherboard is going to have 24 slots, some motherboards are having 48 slots also. Okay, for example, I'm taking a consideration of there are 10 slots are available. If I'm installing 10 slots with a 4 GB configuration, 4 GB configuration, I'm going to get 40 GB total capacity. If I want to upgrade certain configuration, I am looking for upgrade, I need a maximum. I need to understand what maximum I am going to get. That organization account team is going to ask, I need to upgrade this server. What is the maximum support it can support? Now, where I need to go? I need to go to that server specifications, wherein it is going to mention these many slots are available. Each slot can support from 4 GB to 64 GB. Okay. For example, 10 into 8 GB, how much I'm going to get? I'm going to get 80 GB memory. Like that, 10 into, if I install all slots with 16 GB, I'm going to get 160 GB memory. So it depends upon how much memory is required. And at the same time, we need to understand the motherboard capacity. See here, for each and every component, I'm going back and referring to previous one. I'm discussing about memory. Why I'm referring to motherboard? So what are the 5 components we are going to discuss in this particular hardware? We need to understand each and every component. That's very critical for understanding the virtualization layer very effectively, because it is, we are going to work with the multiple servers and performance is going to come into picture. While working on the performance, we need to calculate what is the capacities available and all those things. Okay, hope it is clear. Server memory. Generally in a desktop, in a laptop, only 2 slots will be there. And it can support maximum 64 GB or 32 GB, they are going to mention. Only 2 slots will be there. Nowadays, all brand new laptops are coming with the onboard memory. Onboard memory in the sense, there is no option to upgrade. Okay, so whatever the slots are there, if the free slots are there, we can insert new memory to get more memory configuration. But server motherboard, it is going to have this kind of slots. And see here in this particular picture, these are the white and black slots are there. These are the memory slots. Why? Okay, how many slots are there here? There are 4 here, 8 here, and 4. 16 total, 32 slots are available in this particular motherboard. How many sockets are available? We can install how many
How
processors we
32?
can install.
How
Sorry.
32? How 32? 1, 2, 3, 4, 5, 6, 7, 8. 8 into 2, only 16, right?
See here, this first line, the first line.
Mhm.
How many here?
Yep.
White and black combination, 4 are there. Here,
Oh, okay.
8 are there. Here, 4 are there.
Mhm.
Total in first line, 16 slots. And here, 16 slots.
Okay.
Okay. But we are not going to see physical server in each and every time. What we are going to see is, I'm going to showcase while discussing about, once these topics are over, I'm going to showcase the server model. For example, Dell PowerEdge R630. I'm going to browse that R630, what is the specifications. It is not possible to every time open the chassis and look at the motherboard, how many slots are available and all those things. Okay. By looking at the server model, I should get information. To get that information, first we need to visualize in a reality how it is going to be, how the socket is look like, how the slots are available. Okay. This is important. That's the reason I provided this information. So this is a memory. The memory, we are going to call it as RAM also. Okay. So don't get confused, memory and RAM. Most of the technical people having some clarification, some miscommunication, assumptions, wherein if I ask what is our mobile configuration, they will say that storage, they are going to say as a memory. For example, my mobile, Android mobile, he is having a octa-core processor, and memory I'm going to say as a 2 GB memory, and even storage 32 GB. I'm not going to call it as a memory. I'm not going to call it as a storage. I'm going to say as some memory only. We need to understand difference between memory and storage. Okay, as a technical people, we should not say those technical misconfigurations. Okay, what is memory and what is storage? What is a representation? Even storage also we are going to represent the GB, TB. Even memory also we are going to represent GB, TB. Okay, so this is a memory. So until now we discussed about motherboard, processor, memory. So I'll stop here. I'll discuss about the storage and network tomorrow. Any questions until this particular point?
Oh, yes.
Any
Sir, actually, I
clarification?
want to ask you.
Yes, please.
What is
Actually, I
blade?
joined that. I just want
Uh,
to know this 32
Yes.
you counted, right? Now in the motherboard.
Okay.
Yeah, this one 32. What do you call that? 32 is the processor or what?
Okay. See here. In this motherboard, there are two types of slots we are able to see, right?
Yes.
One I'm calling as a socket, and another one I'm calling as a slot. What is a
Okay.
socket? Socket is to install the processor. How many sockets are there in this
32?
particular motherboard?
Four.
How many sockets?
Four.
4.
4 sockets. Now I'm calling as a slots. What is a slots? We call it as a memory slots or DIMM slots. Okay, we are going to use DDRs, memory slots, memory chips, where we are going to insert those memory chips. These are the slots we are going to use. See here, white and black combination. In this particular first picture here, blue and black combination. You can segregate the socket. Generally, processor socket will be in a kind of square shape. Okay, all processor sockets will be by default. It is a square combination. See here, this is a processor chip. Can I install this processor chip in this particular white and black lengthy slots?
No.
We can't, right?
No.
So that's a segregation, understanding what is the memory slot on this motherboard, what is the socket is available on this motherboard. Clear?
Okay. And sir, what is NVMe interface?
Sorry?
What is NVMe interface? NVMe. It's a drive, right? It is also one kind of drive.
Okay, that is I'm going to discuss about in the storage concepts. Okay, for each concept there is a specific information is available. Whenever that concept is going to come into picture, we are going to discuss. Generally, NVM, it is a controller to use to connect the storage device or disk. Okay, we'll discuss, no problem.
So, 10 RAM put all in one, or 10 RAM divide into 2.
10 RAM divided into 2. I didn't get you.
10 RAM install in one processor in first.
Okay. Let me explain. Generally, see here, if you consider this motherboard, for every motherboard, every server, there is a specification. What processor is linked with what memory slots. For example, here 4 sockets are available, right? 4 sockets are available and 32 memory slots are there. For example, on this motherboard, I'm not going all 4 processors. I'm going with only single processor. Okay. If I, for example, if I'm installing single processor, that specification motherboard manual, that server manual clearly specify if you are going with one processor, you have to install that processor in number 1 socket only. Others will be blank. If you install the processor in number 1 socket, for that particular processor, what memory slots are available? All 32 memories are not available if you are going with a single processor. Again, for each processor, what is a combination of memory we have to insert? Example, I mentioned here 10 slots. When this 10 slots available, if I install all 4 socket processor, all 10 slots available. If I install only one particular processor, only I'm going to use only 3 memory slots only. That specifications, that diagram, that numbers, everything will be available in server manual. As an administrator, as a VMware administrator, I should understand by going through that server manual, the specification manual, how much processor installed, how much memory it can support for each processor, like that. Clear?
Okay.
Okay. If no other questions, please go through this. The video will be published and you can review one more time. And the notes also published by the admin team. So if any doubts, next session, we are going to discuss about previous session. If any clarification or anything, then we'll proceed with next topics. So I'm going to discuss about next session, storage, network, and server models. In server models, what is a tower? What is a rack enclosure? What is a blade server, blade enclosure? What we have in our lab? We have a Dell PowerEdge server. Okay. What is 1U I mentioned? Everything we are going to discuss in next session. So,
hi sir, one doubt I have regarding this server, how to identify how many processors available in that particular server?
okay. Generally,
for example, if we go through the command like msinfo32, in that we will find processor. And how can we identify that how many processors are available in that particular server?
Yes, A good question. See, MS Info 32 is a Windows command. If I go here, I'm going to use MS Info 32. Are you able to see screen?
Yes.
See here, how many processors are there?
One.
It is one processor. By looking at the MS Info 32, I'm going to get this information. While working on server hardware, we have a remote management card and the tools for each hardware, there will be an agent installed on a specific hardware. So by using that agent, by connecting to the remote management card, we are going to get a complete information of the hardware. How much sockets are there, how much memory slots are there, which one is occupied, which one is free. All those information is available while accessing remote management card. In remote management card, there is a feature of inventory category. In inventory, we'll get all this information.
Okay, in Dell servers like iDRAC and for IHS, ILO,
Exactly.
like that, right? Yeah, okay, got it.
HP and
Thank you.
ILO, IDRAC,
Yes.
Cisco UCS, everywhere the inventory option will be there. It is going to populate the information, what is free, what is alerted. Okay.
Okay, thank you.
Okay, that is all for today. Thanks for your participation. Please inform your friends. I'm going to help from the scratch for VMware virtualization. So I'm happy to explain from this each, whatever the layer, whatever the down layman understanding. I'll try to explain each one for your understanding capabilities. Okay. Please inform your friends and provide your feedback. And if any information is required, I'm ready to help and ready to explain. Okay, please post your questions. Should be in a kind of interactive session to understand it is your career. Okay, happy learning. Thank you all your participation.
Thank you,
I'm
Srinivas.
closing. Yeah, bye.